Yes, as Christl says, just want to present some of the implementation we're doing in a research project in which we're trapping badgers and testing them. If they're test positive, then we're removing them. If they're test negative, then they're vaccinating them. So it's kind of the hybrid. One might ask why use this so-called TVR approach. Well, I mean, if you're going to implement it, we'd imagine it being in areas where you've got a high TB prevalence in your cattle population. And as Eamonn's alluded to from studies down south, this kind of correlates with areas where you've got high prevalence of TB in badgers. So by selectively removing test positive badgers, you're decreasing the burden of infection, and by vaccinating those that are test negative, you're increasing the immunity of the population. So the combined effect intuitively gives you an accelerated reduction in your badger TB prevalence and hence in your cattle population. So as I say, intuitively it does provide the best chance of success, provided there's no perturbation effect caused by a selective culling. And it's never been tried out in the field, so this project was kind of part of a proof of concept. The other advantages is that in certainly Northern Ireland it's got the support across all the stakeholders, both farming and veterinary organisations were very happy for this to go ahead, and so were wildlife groups. It's not really been tried anywhere else, so it will add to the scientific knowledge. And as well as that, we're starting from a low base in Northern Ireland, so it will help build up our demographics and badgers and their ecology, and that can be fed into future wildlife intervention strategies. So the objectives of the project were really, obviously everyone's interested in what happens to the badger TB prevalence, but also we're looking at what this does and impact on the ecology of badgers. And I say we're working from a low base, so we're looking at the field logistics of implementation of this and some of the costs of the intervention. And as I say, the data would be very valuable to feed into Graham Smith's models and other similar approaches. A big bonus for us was building up the field experience in trapping badgers. The budget we were giving was a bit limited, so rather than anything fancy, we had to settle for one area which has obvious limitations. So you've no replicates and no controls, so we had to rely on temporal comparisons and before and after design. So this will limit some of the outputs from the study, and I hope we can manage folks' expectations from that aspect. So the area where this is implemented is in County Down, southeast Northern Ireland. It's a 100 square kilometre area. It's bordered by a river on this side, and the main Belfast-Dublin trunk road goes down this side. So there is some soft boundaries there. It's a 5-year study over a 100 square kilometre area. A SIT survey suggested there's about 68 social groups within this area, which is quite high for Northern Ireland. The estimated social group size is usually 0.75 per square kilometre. It operates in over 6 rounds over 3 week trapping cycles. So the region's split into 6 areas, and within the 3-week cycle we've got permissions and land serving as to where we're going to put the traps. The second week's trap deployment and pre-baiting of the traps, and the third week's trapping and cage removal. We have 3 trapping teams, which is all carried out by our technical staff, and vets perform all the sampling. And obviously it's covered out under the required licenses. Just to put some field aspects in it, we just used raw peanuts as the bait. The pre-baiting took 5 to 7 days, moving the bait gradually into the traps covered with a stone. So this all took a week, and then we had about 4 days of trapping, and hopefully that was the end result. So for the badgers we trapped, as I say, the sampling and drug administration was carried out by our vets. Anaesthetised by injection by the standard protocols as used in Winchester Park. Every badger is microchipped, so it's got individual identity, and everything is geo-referenced. We tried to maximise use of the badgers that we trapped, and so we took various measurements from them. Samples taken were blood samples, hair samples, various swabs, and the vaccine used was the badger BCG vaccine. Our plan was to use the stat pack, but a few months before we started the trial, it was taken off the market, so the DPP test had to be used, which is the second generation of the stat pack. It's produced by the same company, but with no details on the actual test characteristics, so it was a bit of a leap into the dark, but given it was a second generation stat pack and we had no other choice, we had to go with it. So in the first year, as I say, it was a before and after design. What we did was we tested all the badgers vaccinated and released them. And it's only in years 2 to 5 that the test positive badgers were being culled and obviously subjected to post-mortem. And the test negative ones, as I say, were vaccinated with the badger BCD. This is a DPP test. As Eamonn showed the stat pack, it's a slightly different setup, but it's got some very similar antigens used to capture the serological result. As well as testing in the field of the blood samples, they were also duplicate tested in the laboratory, so that we could see how well the blood test performed in the field rather to the laboratory. We also did gamma interferon testing on them and cultured the swabs from the oropharyngeal and tracheoaspirates, and any bite wounds were sampled as well. Hair samples were taken from all badgers for genetic profiling, and badgers that were test positive were obviously post-mortem. And all bovis culture from badgers were put into another project which we're looking at whole genomic sequencing of badger and cattle isolates from this area. And the archaeological studies, as I say, all the badgers microchipped, so we have a lot of capture-recapture data, and we also have the badger genetics, which we'll be looking at genetic mixes within social groups over the 5 years. We also deployed GPS collars on badgers. We aim to deploy about 40 collars across 20 social groups, putting them on adult, female and male as far as possible within each social group, so we can monitor the ranging behaviour of badgers. A lot of data to capture, we went for an IT solution where we had real-time remote data capture using Trimbos, which give us very, very accurate geospatial recording of the data, and a real-time feed of our data into the laboratory, so they knew exactly how many badgers were coming so they could prepare for the samples coming. And during the first year we had over 250,000 data points, so it saved a lot of time and effort by use of this system. We had very good cooperation from the landowners in the area. We've got well over 90% access to land. Some preliminary results. This is the number of badgers caught over the first 3 years of the study, and we've just about hit our target of culling 40 odd badgers. We're set a budget limit of 1.5 million per year, so we've managed to keep within that. Unfortunately, well, not fortunately, but all the results are, all the rest of the results are blinded until the end of the trial, so that we don't introduce any biases into it. But the output measures we'll all be looking at in badgers, obviously, the seroprevalence of the badgers, and then by latent class analysis through the tests that we have, we'll be getting an estimate of the true prevalence of the badgers each year to see how that goes. And then we've got the PM results. we're also monitoring cattle. As you've heard from previous talks, I mean, there's quite a lag between impact in cattle, and even bigger lag and impact lag in cattle after the badgers. So because it's a 5-year project, we're not likely to see anything particularly stuck to the one area. But we have, this is the area where we're intervening here, but we have got 3 hands-off areas, sort of control areas, which we can maybe try and compare. But even that, I think the sample size is going to be unlikely that we'll see a statistically significant difference. But we can measure trends, both over time and spatially, to see if there's a trend coming out over the area. And obviously we are measuring in the buffer area just to see if there is any perturbation effect. The other studies, as I say, we're looking at spatio-temporal associations as far as genetic sequencing of the Bovis isolates. That's a separate project though, but it's superimposed on our TBR project. And as alluded to, the thing is, will selective culling cause perturbation? Again, we're using the 3 measures to look at this. We have the capture-recapture analysis, and also looking at genetic mixing within social groups in the hair samples, and also the ranging behaviour used by the callers. This is just some of the printouts from our first year to show the kind of area we're looking at. So, in conclusion, I mean, it has the advantage that everyone seems on board with the TBR approach. The study is a bit limited, but it will supply information into our future strategic planning, and it certainly improved our knowledge and experience with working with badgers. As I say, managing expectations is quite an issue, in that we've only the one area with no replicates and no control areas, and as I say, the lag effect in the cattle TB levels, we're likely to see anything there. But we're very pleased with farmer participation. We've had no problems there at all, and the staff have taken to this like ducks to water and really enjoy the work. We do have a few PhD studies superimposed in this, looking at other aspects of badgers and badger-cattle interactions. And if you want some more information on it, we do publish an annual report on the project on the website. Thank you very much.